we're going to do 18 through 21. So Mrs. Muggenbuffen collects stuffed animals. She purchases the same number of animals on eBay each week. 3 weeks after she began collecting, she had 13 animals. 7 weeks after, she had 25 animals. How many animals did she have when she began? So we know here that in a table format, 3 weeks later, she had 13. 7 weeks later, she had 25. Now, if we're trying to go back to find the initial value, we need to find the adder, how much is being added each week. So we take the change in the output divided by the change in the input. We can calculate what that adder is. So we have 25 minus 13, 12 divided by 4. The adder is 3 each time. So if we go backwards here to go to the 0 term, we'd have to subtract 3, 1, 2, 3 times. So subtract 3, subtract 3, subtract 3, and we get to an initial value of 4. So she started with 4 animals. How many new animals does she acquire each week? Well, we just found that that's the adder. She gets 3 more each week. Write an explicit equation. So T of n equals, this is an arithmetic pattern with an initial value of 4, adder of 3. A recursive definition has 2 parts. One is to give the initial value of the sequence, followed by the recursive rule. So the next term in the sequence is always the current term plus 3 each time. Will she ever have exactly 91 animals in her collection? So if we check whether our recursive or our explicit rule ever reaches 91, if we tried to solve for how many weeks it would take, so 91 minus 4, 87 equals 3n. And then if we did 87 divided by 3, we get that that happens exactly at 29 weeks. So yes, that will happen, and that happens 29 weeks later.